All right, 2.3. We're going to be adding, subtracting, multiplying, and dividing square root radicals. Just square root. Okay, so product, multiplication. If you have, like say, a square root of AB or a cube root of AB, we're going to be talking about square roots in this one. So of AB, it's the same thing as the square root of the A times the square root of the B, or cube root of the A times cube root of the B. All right? So what do we do? When you multiply expressions, terms that are on the inside of the radicals can be multiplied together, and terms on the outside can be multiplied together. So inside, inside, outside, outside. So merge the 2 or 3 radicals together by multiplication, then simplify all at once. So we have 12 times 8, okay? Radical 12 times radical 8, but still 12 times 8, which is square root of 96. And now we need to simplify that and see what perfect square goes into 96. And if you work backwards from 96 and divide, you will find out that 16 is the biggest perfect square that goes into 96 6 times. So we write the perfect square first, and that leads us to 4 radical 6, or 4 square root of 6. Now in this one, there's 2 ways to go about this. You can multiply those 2, okay, and get a bigger number, 64, okay? So you'd have 3 times the square root of 64, which is just 8, and 8 times 3 is 24. But if you noticed, the square root of 4 is just 2, and the square root of 16 is just 4. So there you are, 3 times 2 times 4, 3 times 8, same thing. So sometimes you may be able to simplify a radical first if it's a perfect square, which will make it easier. All right, number 3, we have outside times outside. So 5 times 6 is 30. Z times Z is Z squared. Remember, we keep the base, add the exponents. Now on the inside, 6 times 8 is 48. And x squared times x cubed is x to the 5th. Now, if you notice, you could have brought this x squared out immediately because it was a perfect square, but that's just an option. Now we need to break down the 48 and the x to the 5 and simplify it. So we need a number that goes into 48 that is a perfect square, and that's 16. 16 times 3, and again, those are square roots. Now remember, whatever comes out is going to be multiplied by this 30. So the square root of 16 is 4, and 4 times 30 is 120. Now the z squared is still out there. And we're going to leave a little space here. The radical 3 is stuck on the inside. Now we're going to do 5 divided by 2, which is x squared. And it leaves an x inside, just like we did the previous sections. Now, some people will want to put the x squared before the z squared alphabetical order, but it is not required. They're the same thing. All right. Negative 6 times 4 is negative 24. Let's try that again. Negative 24. Okay? Now, the C just tags along. On the inside, again, we could bring this 4 out as a 2 right away and keep things simpler. Either way, though, you're going to get the same answer. So 6 times 4 is 24. Okay? And then c cubed and c to the 1 is going to be c to the 4th. And d to the 5th and d squared is d to the 7th. Now, we're still going to end up bringing the 4 and the 6, which if you look at that, that's the same 4 and 6 we had at the beginning. So you're really going to do the same thing one way or the other. Now, when the 4 comes out, square root of 4 is 2, times that negative 24, which gives us negative 48. Now remember, that radical 6 is still stuck inside. Now we had a c out there, and we have one c inside. That can't come out because there's only one of them. We need at least 2. And then d to the 7th, we're going to do 7 divided by 2, which is 3. And that's going to leave 1d on the inside. And we're done. Now, I'm going to erase that real quickly and just start over, sort of, to show you how you could have just saved a little bit of time or done it differently. Not a big deal. So I could have recognized that this 4 would come out as a 2. Times 4 is 8. Times negative 6 is negative 48. And I could have done the negative 48 right away. And then I just have the 6 here. And then I deal with my C's and D's like I did before. So I just want to show you that little part. You could have done that to save maybe a step. It's up to you. Number 5. 5 times 3, 15. A1 times A2 to the 2 is A to the 3. And the B just tags along. Now we're at the radicals. Okay. 12 times 18. Kind of a bigger number, but you have calculators, is 216. And then we have A1 and A1 on the inside, that's A squared. B to the 4th, B squared, that's B to the 6th on the inside. And now we get to work. We have to find a number that goes into 216. That's a perfect square. So we just work backwards on the calculator until we find that magic number. And that magic number, that perfect square, is going to be 36 times 6. So now we just simplify. 36, square root of 36 is 6, times 15 is 90. So we have 90 on the outside. We're going to have a radical 6 on the inside. Okay? Then we have one group of 2. Okay, so 2 divided by 2 is 1, but we already had a to the 3, so that's going to give us a to the 4. Because we had 3 groups, and now we're bringing out 1 group. And then 6 divided by 3, sorry, my bad, 6 divided by 2 will be 3, but we already had 1, so that will also give us b to the 4 there. Notice how there's no letters left inside, so it's just 90, a to the 4th, b to the 4th times the square root of 6, and that's it. All right. Now to add and subtract, we need like radicals, just like we need like terms. So on 6, we've done this before, 7x's plus 8x's is 15x's. It doesn't matter what we're adding, whether it's x's, radical 5s, dogs, you're just adding like terms. So here we have 2 of these and 8 of these. That's 10 of these. What are these? Radical 3s. Here, we have 3 of these minus 10 of these. Well, 3 minus 10 is negative 7. What are these? Square root of x. Okay, now, in this case, radical 8 and radical 50 are not the same. But if we simplify them, there might be. So, this one is going to break down to 4 times 2. Don't forget to bring this 4 down. Square root of 4 is 2, and the radical 2 is just going to stay. Plus, this 3 is going to come down here. Radical 50 is going to break to 25 and 2. Well, square root of 25 is 5, which is going to be multiplied by the 3, and the radical 2 just stays. So what do we have? 4 times 2 is 8, radical 2, plus 3 times 5 is 15, radical 2, and 8 of these and 15 of these is 23 of these. What are these? Radical 2's. So we're just adding this object that has the name radical 2, the value radical 2. All right, 48. Don't forget we got this 2x out here. 48 is going to break down to 16 and 3. 27 is going to break down to 9 and 3. Notice we're going to have the 3 in common. So 2x times what comes out, square root of 16 is 4, radical 3, minus the 5, can't forget to bring that down, times the square root of 9, which is 3, radical 3. Then we just simplify. Oh, but don't forget we have this x squared here that's also got to come out, which is going to be an x, because 2 divided by 2 is 1. So 2x times 4 is 8x, radical 3. 5 times 3 is 15x, radical 3. And 8 minus 15 is negative 7, radical 3s. Last one. Got a lot going on here. Okay, so nothing can be simplified here. Nothing here. This one can be, and this one can be. So on the minus 9x squared, we have, x cubed. We're going to take the x out and the 3. Okay, so this is going to become minus 3. Square root of 9 is 3. 3 divided by 2 is 1. And it's going to leave an x inside. Plus 2 times the square root of 100 is 10, square root of y. So what do we have here? We have 5x radical x minus 3x radical x. Well, 5x minus 3x is 2x radical x. If it helps to clear it out so it's not too confusing. Now remember, this right here is going to be 20 radical y. So what we have is 7 radical y plus 20 radical y, which is 27 radical y. And we cannot join those radicals together because radical x is not the same thing as radical y. Also, the 27 doesn't have an x with it. All right, last thing, distribution. So we've done this before with variables, okay? So if you think about it, this kind of looks like 2 times 4 minus x. And we would get 8 minus 2x. Same concept. It's just going to be 2 times 4 is 8. And 2 times negative radical 6 is simply 2 radical 6. Just like this is simply 2x. Here, 3 is an outside number. There's no radical, but it's an outside number. So it's going to be multiplied by the 5, which is 15 radical 2. Now, on this one, we're going to do outside, outside. So 5 times 4 is 20. And radical 2, radical 6 is radical 12. Now, you must always stop and see, can I go further and simplify? Yes, you can. This is 4 times 3, radical 4 times 3. This becomes a 2 times this 20. So that gives us 15 radical 2 plus 2 times 20 is 40 radical 3. And again, those radicals are not the same, so we are done. And now here we have a double distribution or a FOIL, whatever you want to call it. So I'm going to go first times first, the 2 times the first term, that's 6. 2 times the negative root 3, so that's negative 2 root 3. You just tack it on. Radical 6 times 3 is plus 3 radical 6. Always put the coefficient in front. And last times last is negative 6 times 3, 18. Now, right now, nothing looks like it can go together. But this will break down to 9 and 2. So we have 6 minus 2 root 3 plus 3 root 6 minus 3 root 2. And guess what? There's still nothing that can be joined together, but you did simplify this radical, and that is required. And then here, 3 plus 2 radical 7 is really just this. Okay? So you can FOIL it like the last one, first, outer, inner, last. Or the shortcut is, you square the first term, because you would do the 3 times 3. You do this times this and double it. So 3 times 2 is 6 radical 7. Double it is 12 radical 7, because you would double it because the outside and inside would be the same. And then this one, which is a little bit tricky, we have 2 radical 7, we're going to come off to the side, times 2 radical 7. Well, 2 times 2 is 4, and radical 7 times radical 7 is radical 49, which is really just 7. So the shortcut is whenever you do a radical times itself, the radical goes away and the number stays behind. Okay? So what you really have here is 4 times 7, and that's 28. And that ends up being a number which will simplify here to 37 plus 12 radical 7. And that's it. On to the last page. All right, dividing radicals. Okay, there's lots of ways to divide radicals, but this is a very important rule. A radical cannot be left in the denominator. Okay, it's considered not simplified. So the way we get rid of it is by rationalizing. So we have a square root of 3. Remember, things come out in groups of 2. So if we could have another square root of 3 here on the bottom, that would simplify to just 3. But whatever I do at the bottom, I must do the top. So on the top, I get 5 radical 3. And on the bottom, I simply get 3. Always check to make sure these can't be reduced, but we're done on this one. Okay, this is really the square root of 1 over the square root of 18. Now, I could multiply by the square root of 18 and get do this. Okay, so on the top, I would get the square root of 18 over 18. But this can be simplified to 9 and 2. So the square root of 9 is 3. So the top is really 3 radical 2 over 18. And again, that can simplify. Now be careful. The 6 does not go on the top. The bigger number is on the bottom. So this is radical 2 over 6. Okay? Now, I'm going to erase this and show you another way you could have done it. Doesn't really matter, but just another way of doing it. You could have simplified this first. Square root of 1 is 1. And you could have broken this down, 9 and 2, right away to 3 radical 2. And then all you would have to do is multiply by radical 2 on the top and radical 2 on the bottom. That would have given you radical 2 on the top. This gives you 2 times the 3 is 6. So it's not a big deal. It is a little bit quicker. It's up to you. But basically, I was rationalizing radical 2 instead of radical 18. So I did my simplifying first. Either way is good. It's just what you like. Okay. You also want to look and see if the numbers can reduce. So like in this case, 16 and 25 do not have any common numbers, but they are perfect squares. So 16 is 4 and 25 is simply 5. And then on the top, we're going to have, 5 divided by 2 is 2, but we still have a radical y stuck in the top. On the bottom, x to the 4th, 4 divided by 2 is simply 2 groups, x squared, and we're done. We don't have to rationalize. So always simplify first, because if you did this problem and actually multiply by 25x to the 4th, you'd be creating so much more work for yourself. Okay? Now, like I said, if you can simplify the numbers, it will make your life easier. So if you can find that 147 and 27 are both divisible by 3, you can reduce this first. So 147 divided by 3 is 49. Oh, perfect square. And 27 divided by 3 is 9. Oh, perfect square. Life just got a heck of a lot easier. Then y to the 6th on top and x squared on the bottom. Perfect squares all around. So the square root of 49 is 7. 6 divided by 2 is y cubed. Square root of 9 is 3. X squared, 2 divided by 2 is 1. We're finished. So life got a lot easier by just reducing it first. And last but not least, we have something called the conjugate. The conjugate is the same thing with an opposite sign. That's it. So just like this. Those are conjugates. Okay? So we need the conjugate to rationalize these. Because if we just multiply by radical 2 here, top and bottom, then the radical 2 would get attached to this. And we would be playing whack-a-mole because the radical would just jump back and forth. Okay, so what we need to do is multiply by 3 plus radical 2, top and bottom. Now be careful that you put parentheses here so you distribute that 5. Most common mistake. 5 times 3 is 15, and 5 times radical 2 is simply 5 radical 2. On this one, the inside and the outside are going to drop out. That's the beauty of this one. So you just have to do Florida, FL, first and last. 3 times 3 is 9. This is always going to be a minus. And if you don't have a minus down there, you made a mistake. And remember, radical 2 times 2, radical 2 is simply 2. So what does that leave us? You cannot combine these two. You can't say 20 radical 2. That'd be like saying 15 plus 5x is 20x. It's not. They're not like terms. This stays 15 plus 5 radical 2. 9 minus 2 is 7. Again, check and see if they're divisible. They're not. We're done. But if this number on the bottom ended up being like a 5 or a 10, you could reduce all the numbers. But you have to reduce all of them, not just some of them. Okay? Now, I'm going to erase something. You don't have to write this down, but just look. If this was a 10 right here, okay, you'd have to cancel with all 3, not just these 2, and get 3 and 2. You'd also have to do this one. And that happens a lot where people only do 2 of them. So please be careful with that. I'll put it back the way it was. Whoops. Wrong button. Never mind. All right. I meant to do that. There we go. All right, last one. Again, we want to rationalize with 1 minus radical 7, the conjugate, top and bottom. This one's a little more complicated because I'm going to have a double on the top. I'm still just foiling, or double distributing. 2 times 1 is 2. 2 times negative radical 7 is minus 2 radical 7. Then I'm going to have inside, which is going to be 1 times negative radical 5, which is just simply negative radical 5. And then last, negative times negative is positive. 5 times 7 is 35. And notice nothing up there will combine. Okay? They're all different radicals. Can't combine them. It's kind of ugly, but that is how it is. On the bottom, we just do 1 times 1. A minus always, and then the radical disappears, we get 7. So the only thing we need to do here is write this again, 2 minus 2, radical 7, minus radical 5, plus radical 35, which does not simplify, and negative 6. Now notice, this is what I was talking about before. You cannot cancel, don't write this, you cannot cancel those and those, because there's no even number here and no even number here. Okay? So you can't pick and choose. It's either all or nothing. So you can't factor 2 out unless everything has at least a 2 to take out. So that is the end of the problem right there.